Ionic bonding. Ionic bonds are the electrostatic force that hold ions together in an ionic compound. So, ionic compounds are usually formed between metals and nonmetals. So that's a clue to telling you if something is an ionic bond. Non-metals have a low electronegativity, so they do not really want the electrons. So they kind of want to give away their electrons. And nonmetals really want electrons. They have a high electronegativity. And due to this, to the difference in their electronegativities, which is pretty great, they take, they transfer their electrons, they transfer all of their electrons to another atom, and then the other one loses the electrons that it wants to lose. They do this so that they can remain stable and have 8 valence electrons in their outermost shell. So by giving away electrons, they also get 8 valence electrons in the maybe their lower energy level. So it's easier for them to give up 2 electrons, let's say, or 1 electron to get that 8 valence electron. While for nonmetals, it's easier for them because they have a high electronegativity to get 1 more electron or 2 more electrons to get that 8 valence electron, to get those 8 valence electrons in that valence shell. So a common example of an ionic bond is formed, ionic bonds, compounds are formed with ions. They are an atom or group of atoms. This is very important. They can also be a group of atoms, so it can be an atom or group of atoms that has a net positive, so they have a charge, and or a net negative charge. So a common example of an ionic bond is NaCl. This is table salt. So something that maybe all of us have had before. And so Na has a positive charge because it's a metal and it wants to give away its electrons, and only one because it only has one to give away. And then Cl has a negative charge, and this is because it took or transferred, the Na transferred its electrons to Cl so that Cl could have a whole octet or 8 valence electrons, so a whole octet, so that they can remain stable. Notice that all bonding that happens between compounds is because those elements help each other stay more stable. Now, there's a thing called oxidation number. It's the number of charges the atoms would have in a molecule or ionic compound if the electrons were transferred completely. So the oxidation number for Na, let's say, would be 1 because it has transferred 1 electron to, or 1 positive electron to another atom. So that's what oxidation number is. Okay, it's something that tells you the number of charges the atom would have in a molecule if it were transferred completely. Now, it's also important to remember that ionic bonding means that they have specific names. So Na has a name, sodium chloride. Notice Cl is usually called chlorine, but when it's bonded together with Na, we call it sodium chloride. And we'll learn more about how to name ionic bonds later. And so in line with naming, we have a stock system for transition metals because transition metals sometimes have different positive charges. So let's say it has a 2 positive and then a state that has 3 positive. So it's given away 2 electrons, or it maybe have given away 3 electrons. So when a bond ends, or when you're naming an acid or something like that, you put OUS for the cation with fewer positive charges. So you would put 2 plus, let's say, for an element that has lost 2 plus electrons, so 2 electrons. So Fe, let's say 2 plus, and Fe 3 plus would have 2 different names. It would have this Fe, because it has the fewer positive charges, would be us, would end with us. Or we would use, instead of Fe stands for iron, we would use its Latin name because this comes from the Latin. We would use ferrous. We would call this ferrous. And for the one with more positive charges, this cation with more positive charges, we would call it ferric. So remember, for ionic bonding, it happens between metals and nonmetals due to the difference in electronegativity, so how much it wants to give an electron or take one, so that they can become stable. This happens between ions, and remember, it's the electrostatic force formed by having the charges that they do that help them stick together. They have oxidation numbers based on the number of charges, and also different names based on their charges and because they are in ionic compounds.